Howdy. Well, today we'll just do a few quick demos of MCU Resource Maker, and to start it off we'll just do something simple like import a video. Actually we'll do a few and show what it can actually do. So basically I've come in, just started it, get the main screen. To the left here is the navigator. Don't really need that, so make that disappear. Use this option here. Basically it's what I would call power tools. Click on that. Only thing that's available at the moment, oddly enough, is convert video, because everything else requires image frames and things to be actually active, so we'll choose that. Pops up over here somewhere. Don't really need the bottom of it because it's not showing, but anyway, let's see. You got a few tabs here: input, output, save, and this one here. Basically the last one, FFmpeg, just shows the log of what happened in the last conversion. Don't really need that unless something goes wrong. Go to input. Obviously nothing's been loaded, so we'll go and load something. So just click on open. Just happens to be a heap of them on my desktop. So we'll pick something that's fun. Well, let's see, there's one that I've got here. It's just a little robot head. I forget what he says. He says something like the temperature and a few other things, and that's about it. Very short. Load him up. And it has a look. We don't want to fill the thumbnails. That doesn't make any difference to the output anyway. Tells us there's 66 frames. This was actually saved in 128 by 128. 14.99 frames per second, so take that as 15. 32k hertz, 16-bit sound. You can use the slider. By default, first frame will actually be the first frame and the last frame will be the last one, so if you don't do anything here you'll get the entire movie or clip, whatever it is. So we'll have a bit of a look. The output options. Okay, let's say we'll leave it at 128 by 128. The drop down's got a lot of other options. I can add more quite easily. They basically correspond to a few small devices. So 128 by 28 is good for us. RGB 565. Now the LE, as opposed to the SPI order. Little endian and big endian. What's the best way? Well, if you're making this for Arduino, really you want in SPI order. That's the most significant byte first. And if you're doing screen manipulation and all that, you just want to display it or manipulate it, you probably want the other order, LE. So for our case, we'll put SPI order. The next one's the dithering. Now, most videos are stored as 24-bit red, green, blue, and since we're going to RGB 565, you can get banding on some, so it's good for any of these just to have a bit of dithering. Just the first one doesn't make much difference for this. FX, this means whether to show all the effects or not. Preserve aspect ratio, usually want to do that, fill all pixels, just experiment. Now we're going to put the large stamp, and let's see, we'll put the fast Fourier transfer on, and let's see, well, it hasn't come up because we've told it there's no sound, but we want sound. It's got sound. Probably want 8,000 hertz. Now it all depends on the original frames per second. Let's see what we've got, 15, so it's pretty low, so that's good. Don't want to overtax it, so 15 frames per second is pretty low. 8K, that's fine, original frames per second. So this is what we end up with, and we can use the slider to sort of view it. Yeah, that's roughly what it is. It doesn't actually show the fast Fourier transfer here, but that's alright, that's calculated. And this is a nice short one, so what we'll do, actually rather than be boring and have it in colour, we'll do something like make it grey 16. So this is well, on here oddly enough it's called grey 16, and on here it's grey 4. It's actually 4 bits per pixel, but it's got 16 shades of grey. And that looks pretty good. Now, if you don't have any dithering on, well, it's a little bit harder to see here, but you can get a lot of banding. This one hasn't got much colour anyway, so it doesn't really show up. So we'll actually make it go to, we'll lash out, make it grey 4. Now you can see the difference. It's only got black, white and 2 shades of grey, and it's 2 bits per pixel. So I'll put this dithering back on, and you can see the difference it's made. If we go back to 16, you can see the difference between the two. Right, so I'll leave it at this 2 bits per pixel. Go to save, go to render, choose a file, just stick it on the desktop, let's call it F1. I've already got one called F1, doesn't matter. Yes, I want to replace it. And it comes up, boom, done, process 66 frames. Okay, and hit close. And if we then open it, so we go to File, Open, and we've got all these LMB files. Here's our F1, 298K, and there we go. We've got the navigator, scale it down so it's 1:1. So I'll make that go away. Now with the latest version you can actually use the mouse wheel to scroll through, so I'll do that. You can see each frame. You can also see the audio changing. You can't hear it, but according to this, yes, it's got 8,000 Hertz audio, and it tells us for every video frame it's got 533 bytes of audio. It tells us a few other things. So yeah, basically it's grabbed the video and chucked it into a format that we can load into our Arduinos. It's got 66 frames, 0 to 65. So yep, that's it. Basically go in there, choose your video, choose your format, choose whether you want sound or not, and the rate. For a lot of other ones, they might have 30 frames a second, and unless you really need 30, I would halve that down to 15. 15's good. 12.5 is good if it was 25. If it was 24 frames a second, chuck it down to 12. It all depends. If you've got a format like this one here, it uses a lot less to load it in, so there's trade-offs everywhere. If you want 16 bits per pixel color, then well, you should sort of compromise a little bit with the frame rate. It really depends on your end hardware. If you've got one of the newer TNCs, well, it should handle quite easily the 16-bit and say 25 to 30 frames per second with sound, it should be able to do that for this small resolution. If you've got a higher resolution, you're going to have to drop your frame rate back. It really depends on the end hardware, but this gives you the choice of mixing and matching. If you've got, say, a 320 by 240, then you should be able to show it in, say, 1 bit per pixel quite easy, or 2 bits per pixel, even 4. It really depends on how fast you can get your SPI bus moving. So anyway, that concludes this, and we'll have another short one soon. Bye.